Physics 20 and welcome to my kitchen. Please excuse my dishes. I haven't done dishes today. So what we're going to do, this is our field trip lesson for you regarding free fall. So what we're going to be doing is we're just going to be comparing a couple of different items and how they fall and comparing wind resistance. So remember how all items on the planet Earth, when you're close to the surface of the Earth, are going to fall with an acceleration of 9.82, it's Monday, 9.81 meters per second squared. We're going to be testing 3 items today and comparing the rate in which they fall. I don't have ticker tape or anything, so we can't actually do a demo lab at the moment, but we're going to work with what we got. I have a piece of paper that I filched from recycling. I have a book, and I have a ball in which I borrowed from my dog. She's at daycare today, so she's not going to be leaping into the videos, sadly. It would have been cool if she was, but she's not. She does that in some other videos later. You'll see. Okay, so while we're at it, this is a great book, by the way, guys. The Martian by Andy Weir. I highly recommend you guys read it if you haven't. The math and the physics and the chemistry in this book and the bio, all accurate. Like the physics and the calculations have all been vetted by like actual astrophysicists, and this guy does like orbital dynamics as a hobby. So like he knows his stuff. I think at one point he spent like an entire day doing all this math just to make sure he could say put one number in the book correctly. So it's awesome. The movie's okay. But it didn't ruin the book. But the book, a million times better. Read it. Okay. So it's appropriate because we're doing a video on gravity and the physics. It's all good. So first we're going to compare. I'm going to back up so you guys can see these items hitting the floor. And you guys can kind of see the floor. That's maybe too far. That's good. Okay, so we've got the book and the ball, and we're going to drop them. Okay, so notice, ladies and gentlemen, how both the book and the ball fell at the same rate. Okay, so 2 objects, both accelerating 9.81 meters per second squared. I can tell you for sure, just by holding them, that the book is heavier than the ball. Well, let's compare something significantly lighter with the book. Let's look at the paper. Well, what is going to happen here when I drop the paper and when I drop the book? What do you think? Make a hypothesis. Make a prediction. Okay, you have a prediction. So, I'm going to drop them. Paper, book. Well, the paper fell at a significantly slower rate. Why is that? If you said friction and air resistance, you are correct. 5 points for Gryffindor. Well, I'm a Hufflepuff, so it's 5 points for Hufflepuff? Whatever house you're in, 5 points. So, Harry Potter reference, awesome. So guys, the reason why is air resistance. Air resistance is not something that we calculate in Physics 20. That is something that you will be calculating in future years, because we don't do it in Physics 30 either. So, but just so you can see how air resistance and friction changes the motion of the object. We will be looking at friction in dynamics, the dynamics unit, later. So what we're going to do with our ball of paper is we're going to crunch it up. And by crunching it up, I'm going to reduce the air resistance. Have I changed the mass or the weight of this paper? And yes, mass and weight are different things. We'll see that in the dynamics unit. So no, I have not changed the mass or weight of the paper. I am now going to drop said mass, both masses, and observe, ladies and gentlemen, they fall at the same rate now that we've reduced the air resistance on the paper. Okay, well, why didn't the book demonstrate the effects of air resistance in this case? Well, because the mass of the book is going to give it a larger, gravity's going to be acting with more force on the book, which means it's going to have resistance in the form of air resistance. It's not going to be as visible. So that we'll look at that later on in the dynamics unit, but just a lovely little field trip, I guess. Field trip to my kitchen for your physics lesson today. All right, ladies and gentlemen, I hope you guys enjoyed that. Have a good rest of your day and no fires, injuries, or explosions.